Okay. Okay, hello everybody. We are going to go over chapter 6 today, and chapter 6 is on the discounted cash flow valuation. And this is a follow-up to chapter 5, which you did, where we found how to calculate the future value and present value of a single sum. In this particular chapter, I'm going to minimize this so we have more space. In this chapter, the difference is that we are going to be looking at the present value and future value of a series of payments, what we call annuities. So let me just kind of try and give an overview of the chapter. So in the last class, what we did is we said, look, if I have a certain amount of money today, let's make it 5 years, and let's say it's $100. Can you tell me what the amount will be in 5 years? And then all we did is we took the future value of this, earning interest at a compounded rate. So if we were using the formula, we would say future value is equal to present value 1 plus r to the power t, or future value is equal to 100, and we need to put an interest rate. So let's say the interest rate was 10%, then we'd say 1, and then when you're using the formula, you have to use decimals, to the power 5. And if I take my calculator, let me get that, and then I'll explain the calculator. Then that will equal to 161.05. How did I get that? Well, I took 1.10 and took it to the power 5. So let me do that. 1.10, I press the YX button, 5 equal to, I get 1.61051. Multiply that, and I get this number. Now, if I wanted to use the calculator, what would I do? I would say, put -100 for your present value, 5 is your N, 0 is the payment, 10 is the interest per year, compute future value. And I'm using the BA2 plus for that. So that was to find the future value. And we said, look, essentially what that is if you put the money in a bank earning 10% over 5 years, it'll become 161.05. The next we did, but remember now, this is just one number, right? One figure sum. Same thing is true when we did the present value. We said if we had, or if we are expecting, remember we always put 0 for today. If we are expecting $200 5 years for today, what is its value today? Or what is its present value today? We work under the assumption that there's an opportunity to invest, so the opportunity cost is positive. We need to find out what money we need today so that when we put in the bank, it will grow to become 200. So let's assume the interest rate in this case is 5%. So we can do it two ways. We can use the formula. Remember, the future value formula was present value 1 plus r to the power t. Well, to find the present value, we just bring this term over here. So it'll be as follows. So for this particular example, 200, the interest rate is 5%, and it's for 5 years. So if I do 1.05yx5 equal to, I'll get 200 divided by 1.27628. 28, and I'll save this and divide it by that number, and I get $156.71. How would we explain it? We'd say, listen, if you had 156.71 and you put it in a bank at 5%, it'll earn interest and then interest and principal again, interest, and will accumulate up to $200. If you don't wish to use the formula, you can use the calculator. In this case, you're computing the present value. So you'll put 200 as your future value. 5 is the N. 5 is also your interest per year. 0 is the payment. And then you say compute present value. So let me just double check. 0 is the payment, 5 is the I, 5 is the N, compute present value, and it's 156.71. So once again, this is just one number. This is the sum that we want to invest in. Now I'm going to go and have multiple pages. So what chapter 6 does is the following. It looks not at one sum, but a series of payments. Okay? So when we mean by a series of payments or an annuity is the following. It means any form of payment, so it could be a 90 number 175, but it has to be the same number and spread over equal periods of time. So in other words, an annuity is defined as a series of equal payments made over an equal period of time. So when you have such a cash flow, then let's say we need to find out the present value of all of these or the future value of all of this, then we cannot use just that formula, but we'll have to go beyond that. And so we will go back to our notes and do the problems that are there, which are taken straight from your textbook. So once again, the difference between 5 and 6 is that in 5 and 6, we are finding the present value of one number. We call it the one particular cash flow. Or we're finding the future value of one particular number. But when chapter 6 comes, we are talking about finding the present value of a series of payments that are equal, and we're either finding the present value or the future value. Now we'll also do what are called unequal cash flows, but that will come shortly after we finish the first set here. So let me just go over it again. An annuity is defined as a series of equal payments made over equal periods of time. So it could be every quarter, every 6 months, every year. And in the real world, we have a lot of instruments that do provide that kind of payment. And as a result, you have to check and be able to value these payments. So let's start with an example. We have 5 payments here of 2,000. Let's say we have invested in annuity, and this is what we can be expected to be paid over the next 5 years. And the question asked is, what will this total amount accumulate up to in year 5? So that is at the end of year 5. Let's say the interest rate is 10%. So then we always have one way to do it, which is to do it the long way and take each one of them separately. So in other words, let's say you get 2,000 in year 1, you put it in a bank. If you get 2,000 in year 2, put it in a bank, 2003. The question asked is, how much will they all accumulate up to, so we can do it separately? We know that this 2,000 that is over here. Let me just do that. This 2,000 will earn interest for 4 periods, correct? 1 to 2, 2 to 3, 3 to 4, 4 to 5. So we can essentially do the same with the formula. We did that, 1 plus r to the power of 4. This one will earn interest for 3 years, so 1 plus r to the power 3. This one, 1 plus r to the power 2, and this one just 1 plus r. And that last one doesn't earn any interest, and that's one thing you have to be careful about. When we do the future value and present value, that period, the last payment does not earn interest. So if we went, let's say for the first one, 2,000, and the interest is 10%, so it'll be 2,000, 1 plus 10% is equal to 2,200. What about this one here in year 3? Well, that will earn interest twice, so we'll multiply it by 1.10 again, and we'll get 2,420. And then another 1.10, and that will grow to be 2,662. And the next one will obviously be 2,928. So if we add them all together, so we're doing each one of these separately, then we know that the amount we put in the bank will totally accumulate up to $12,210 and $20. So it's a long way to do it. But the alternative is there is a formula. And of course, there's a calculator. And of course, there's also Excel that you can use. But let's start with the formula. So the future value, when it involves a series of payments or an annuity, then the formula changes somewhat, and it becomes, you have to put in the payment, 1 plus r to the power t minus 1 over r. So in this example, 2,000 was your payment. Remember, it's a series of payment. 1 plus 10%, take it to the power of 5, minus 1, and then divide it by 0.10. As you do it in the calculator, you'll see you'll get the same answer. Alternatively, you can use your calculator. And here's where the difference comes. Here, we now have to use the payment button. So by definition, when you put in payment, that means you're talking about an annuity. So there'll be more than one. If your n is greater than 1, then you'll put, let's say it's 2,000, put 2,000, 2,000, 2,000, if it's 3. If it's 10, it'll put 2,000, 2,000, 2,000. So in this example, 2,000 is my payment, 10 is my interest per year, it's for 5 years, 0 is the present value because I'm looking for the future value. And so lo and presto, the future value is 1210 times 0.20 is what it will accumulate up to. Alternatively, there's even a formula in Excel that you can use, but as you know, in this class, you will not be allowed to use Excel in the exam, so you'll have to use your calculator or the formula. But the rule is the straight. You put 2,000 as your payment instead of the present value, and then find the future value. You have to put in the rate, which is 10%. You have to put 0.10. Number of payments, it's 5. A number of periods, as they say, but what's my present value? My present value is minus 2,000. I'm sorry. This is the payment. That's because it's an annuity. So it's, you can put negative, and as you discussed in the last class, excuse me, when you put negative 2,000, it becomes positive as your answer because of the way the algorithm is written. Present value is 0 and type is 0, and type 0 means it's the end of the period payment. And lo and presto, you'll get the same answer when you do that. So I'm going to go do some other examples, but first, let's do a small problem where we combine the future value of a payment and then also do a future value of a sum from chapter 5. And that will become relevant when you look at this particular problem. In this problem, it is saying what is the future value of 3 payments of $1,000 each, beginning in year 1 at 10% in year 8? So in other words, we're only getting $1,000 for 3 years. I don't want to find out what the value is in year 3, but I want to find out what the value is in year 8. So in this case, what will we do? We say, you know what? I know how to find the future value of this number, excuse me, to period 3. Then once I have that lump sum, I can then use the future value of a single sum and bring it over here to period 8 at this point. So we don't actually need these arrows here, so I'm going to remove it for the moment. That's a different problem. So let's do that. How do we find the future value of these 3 1,000s in year 3? Now, before I go that, remember, you can always take this the long way. You can take this 1,000, bring it to period 8, that would be 5 years. Bring this 1,000 all the way to 8, bring it 6 years. Bring this 1,000 all the way to 7 years, and then if you add them up, you should get the same answer. So let's start here. So here's you saying, we estimate the future value of the 3 payments of 1,000 by putting 1,000 is my payment, 3 is my N, 10 is my interest per year, 0 is my present value, and compute future value. And that will give you the number 3310. So we know that at the end of 3 years, your number will accumulate up to 3310. But the question asked is, what is the value at the end of 8 years? So now we have to take a sum, just one number, and move it to period 8. So since you're using your calculator, that's pretty straightforward. Instead of payment now, it becomes negative 3310 is your present value, 5 is your N, 10 is the interest per year, 0 is the payment, compute future value, and lo and presto, you get 533079. So this is a combination of finding the present value of an annuity and the future value of a sum at this point. Okay. So that's where we are. Now, let's do another problem. And what I'm trying to get to you is that this is one of the strengths of the present value, future value, is that you can do every problem multiple ways. And that at the end, if you can get all the cash flows to the right destination, the answer will still always be the same. So let's start with this particular problem. I said, in the last question, we said, what is the value 8 years from today? But what if I change the question and said, what is the value 5 years from today? So you'll say, okay, that's still simple, because all I have to do is to take it to year 3 and then take it to year 5, right? So you'll do present value 1,000, 1,000, 1,000. So I'm sorry, payment for 1,000. N equals to 3, 10 is your I, and you'll get the same 3310. And now you'll take this 3310 2 years forward to period 5. So now it's just one sum. So 0 is your payment, 10 is your interest, 2 is your N, negative 3310 is your present value, compute future value. And what do you get? You get 4,510. But you know, you could have done it the other way. Remember, and I'm just going to flip it back to the previous one. Remember, you got 5,330.79 in period 8. Well, actually, all you could have done is also taken that money back towards here, and you'd still get the same answer, because this is the same 1,000, 1,000, 1,000 that you had taken forward to period 8. So to show that, I'm going to go to the next graph and saying, listen, those three 1,000s, they were worth 5330.79. But my professor changed his mind and said, what is this value in year 5? Well, I could have just taken this backwards and I should get the same answer. So now, of course, this is the future value and I want to find the present value. But going back 3 years, 1, 2, and 3. So 53079 is my future value. 3 is my n. 10 is my interest per year, 0 is my payment, compute future value, and guess what? You should get the same answer, 4,005.10. So what we are basically saying, and I'm going to the next page, that there are many ways to solve future value and present value. It doesn't matter which direction you go or how many loops you take to arrive to the period at which you want it to be valued. So, for example, if you wish to find the value of $100 today in period 5, you could estimate first its future value in period 10, find the estimated value, the same of that amount using 8 years back to period 2, and then move it forward to 3 years to period 5. So in other words, I want to find out something in period 5. I can take the value, go over here, come back here, go over there. As long as I come back to the right destination, the value will be correct. So as long as you can ensure that you are valuing it correctly at the date you want, you should not, you will not make any mistakes at that point. So what have we done so far? So far we have done and find the future value of an annuity, and then we've combined it with the future value of a sum. Now let's do the opposite. Let's find the present value of a series of payment or an annuity, and we'll find out that it's the same principle as we had studied earlier. So for example, let's take a look at this diagram. There's 5 $1,000 that you're getting over the next 5 periods. So 1,000, 1,000, 1,000, 1,000, 1,000 till period 5. But now the question is reversed, and we want to find out what is its value today? How much is it worth to me today? So if we looked at that, of course, we can always do it the long way. We can take the present value of each one of them separately to today and then add them up. So, for example, the first 1,000, how do I find the present value? Remember, present value is future value over 1 plus r to the power t. So in the first case, all I can do is to do 1,000, 1 plus 0.10 to the power 1. So actually all I do is do 1,000 divided by 1.10, and I'll get 943.40. To do this 1 and 2 periods, I can do, because t becomes 2 now, so for the second one, I'll do 1,000 divided by 1.10, and I need to divide it by 1.10 again. And so I can continue to do that, or I can use my calculator. So let's take this 1,000 back. How will we do it? We'll do 1,000 is my future value, 5 is my n, 6 is my interest per year. Oh, I'm sorry, I used 10% for the next, but it's really 6%. 0 is my payment, compute present value, and I'll get 747.26. So I got to change this all to 6 and 6. Okay, that's the long way. Of course, we don't want to do it the long way. What we can do instead is use the formula. So the formula is slightly different than the future value formula. You have to use the payment because it's a series of payment. It's 1 minus 1 over 1 plus r to the power t over r. By the way, do remember that 1 over 1 plus r to the power t can also be written as 1 plus r to the power minus t. Okay, so just for your refresher, 40 to the power minus 3 is the same as 1 over 40 to the power 3. The signs change when you move it from the numerator to the denominator. So if I were to use that equation, what do? I do 1,000, 1, 6 is my interest per year, 5 is the amount of periods, divided by 0.06, I'll get 1,000 times 4.212, and lo and presto, it's the same answer. But I don't even need to do that. I can use my calculator. If I use my calculator, it's straightforward. 1,000 is my payment, 0 is my future value, 5 is my n, 6 is my interest per year, compute present value. If I wanted to use Excel, I have payment, a present value, but now I'm going to fill in my payment one. So it'll be 6%, 5 period, minus 1,000 is my payment, 0 is the future value, and I said the default is 0 for end of period payments. So it's 0, and we get this number. So how will we do a problem like this? Example, I have 3 payments coming in 4, 5, and 6. Now I need to know its value here today. Right there. How much is it worth at this point? Again, there are many different ways to do it. Of course, the long way to do it is to take each one. You take the present value of this for 1, 2, 3, 4 periods. Take the present value of this for 5 periods. Take the present value of this for 6 periods, and then add them up. Sure, you can do that, but there's obviously easier ways. So let's do it this way. I'm going to show it to you in 2 different ways. Remember the principle of value additivity. We can just move it forwards or backwards. So one thing we can do is to find its future value here. And then what we can do is to bring that whole sum over here. So how do we find the future value of these? Well, that's simple. I put in 0 as my present value, 3 as my n, 5,000 as my payment. The interest rate is 11. Compute future value. So if I did that, I'll get $16,750 in period 6. Then I can take this back all the way to 0 as one sum. So then 16,710 is my future value, 6 is my n, 11 is my interest per year, 0 is my payment, compute present value, and I get that number 8934. How about another way, say? I said, okay, let me show you another way. This time, I'm going to find first the present value of these numbers, and then bring it back here. Said, all right, 5,000 is my payment, 3 is my n, 11 is my interest per year, 0 is my future value, compute present value. So I'll find the present value. Now remember, it comes back 1 year. So you're right here in the period 3. So now you have to take it back. How many years back? 3 years back. 1, 2, and 3. So you say, now this is your future value now, because you want your present value. 12,215 is my future value. 3 is my n. 11 is my interest per year. 0 is my payment. Compute present value. And I get 8934.12. So I'm going to go back to the previous slide. I took it forward and I brought it right back. In this case, I brought it back till 3 and then brought it back. It doesn't matter. As long as you bring all those 5,000s back to period 0, you will get the right answer at this point. So in principle, therefore, once you have the calculator, it's either going to be if you're going to find the present value or the future value, but if it's an annuity, you will have to put the numbers in the payment register. If it's only one sum, then it's either going to be you will put in the future value to compute the present value, or you'll compute the present value to find the future value. So having said that, this is for an annuity, and an annuity is when it's a series of equal payments made over equal periods of time. What about if the payments are not equal? Now for that, in your calculator, you have what is called a cash flow button. And I'm going to use the example, as I said, using the BA2 Plus calculator. But once you learn how to use the cash flow button, you'll find even doesn't matter how unequal and how far it goes, it's very simple to find either the present value or the future value of a series of payments, a series of unequal payments to be precise. So we're going to start by doing this simple problem here. I'm expected to get $200 in year one, $400 in year two, and $600 in year three. What is the present value of these payments when the interest rate is 8%? So here, I can first of all always do it the long way. So I'm getting 200 next year. What is its value today? And remember the principle. We give it a value based on what opportunities we have with the money that we have today. So let's assume that you can keep that money in a bank earning 8%. So in that case, I can do using the formula 1.08, 1 plus 0.08 will give me 185.19. Or you could say 200 is my future value, 1 is the N, 8 is my interest per year, 0 is my payment, compute present value. Either case, you'll get 185.19. You do the same for 400 at 8%, bring it back. 600 at 8%, bring it back 3 years. Add them up, and you'll get 1,004.42. Now remember, I told you I have a favorite person, grandmother, who comes into the room occasionally and asks you these simple questions that you have to answer. Well, let's say grandmother says, you know what, I don't believe this is the right number. I don't think it's only worth 1,442. How can you prove to grandmother that this is the right number? Well, what you could tell her is, all right, if you don't buy that, this is 1,000, let's look at it the other way around. Let's say you did receive this 200, 400, and 600. When you receive that money, let's say you put it in the bank and let it accumulate interest. So for example, this 400, if you get it and you put it in the bank at 8%, what will it grow to? Well, I'll multiply it by 1.08, so it's 400 times 1.08 is $432. And this 200, I'll put it in the bank for 8% and then another 8%. So that's 200 times 1.08. Let's see, it's 200 times 1.08 is $216, right? $16 interest. And then it earns another 8% times 1.08, and it's 233.28. Let's add all these numbers up. So it's that plus 432 plus 600 equals to 1265.28. So you got these monies, you put it in a bank. Now I told you that this is the same as having 1,442. Let's see if that turns out to be correct. Let's say you did have 1,442 and you put it in the bank at 8% to earn. So we can either use the calculator 3 times or we can use the present value table. So I'm going to do this. I'm going to take this off and say, all right, let's see how much, oh, that was wrong. I didn't mean to hit this. So I'm going to remove this and say, all right, negative 1,004.42 is my present value. 3 is my N. 8 is my interest per year. 0 is my payment because it's only one sum. Compute future value. Let's see what we get. So 1,004.42, I change the sign, it becomes negative, put it in its present value. 0 is the payment, 3 is the N, 8 is the I, compute future value, guess what? It's 1,265.28. So you can tell grandmother, look, I am right. These 3 payments are, if you want to look at it, what's today at 8%, it's 1,004.42. But if you want to know what's it worth at the end of year 3, it's 1,265.28. So we've understood the valuation, but how about doing it practically? Well, practically, the best way to do it is to use the cash flow buttons in your calculator, and that's what I'm going to teach you right now. Okay, so it'll take you a few attempts to learn the cash flow. Once you learn it, you'll probably never not use it after that. So in BA2 Plus, first press your cash flow buttons. And then I always play it safe. And what I do is I clear the register by pressing second and C/C, which is right at the bottom left of your screen, of your calculator. And that will clean the register. And you know it's clean when CFO shows up as 0. So CFO is the cash flow in year 0. So again, I want to refresh your memory, what it looks like. It's like this. This is 0, 1, 2, 3, and it's a 0 here, 200, 400, and 600. So I'm going to put 0 and then the enter button, which is on your top row, and the down arrow key. So this will store 0 in time period 0. Then it will show up C01. So you say, okay, cash flow 1 is 200, so enter 200. Don't forget to press the enter and the down arrow key. Now, when you press the down arrow key, you will get FO1, and that basically asks you what is the frequency. So I'm going to draw again the numbers to refresh your memory. It's 0, 200, 400, and 600, 2 and 3. So you'll just press the down arrow key because you only have one 200. It's asking you how many 200. Okay, so then it asks you for cash flow 2. And then you put enter 400, enter, and since there's only one, you can press down arrow key, and this will store the 400. So you've taken care of this, you've taken care of this. C03 shows up. You say 600, enter, down arrow key, and you can press another down arrow key if you want to, but you're done. So once all the cash flows entered, the one good thing about BA2 Plus, which you don't get it in the other calculators, is you can push the up arrow key, down arrow key to make sure that you have entered it correctly. If you have not, you just can put the right number on it, which the other calculators don't have. But once you're sure you've entered it in this correct sequence, 0, 200, 400, and 600, then you'll click the net present value button, which is on your second row. And this time it'll ask you for the interest because it needs to know at what rate should I bring all this back right here so I can give you the total value here. So you'll say 8% is the interest, so 8, enter down arrow key. And then you just press compute, and lo and presto, you have 1,004.42. So it's important that you practice this problem before our next assignment in class so that you can do other problems when we give it to you at this point. Now, in Excel, what you'll have to do is you'll use the equal to net present value button. You'll put 0.08, and then you have to put in these cash flows, which are 0, 200, 400, in these cells separately. You can either put it horizontally or vertically, doesn't matter. 400, 600. And then so let's say it's G13 to G15. All right, so this is G13, G14, G15, and G16. You just shade it, and that's it. You press return, and it'll give you 1,004.42. So let's do a more complicated problem. Let's say I ask you and said, by the way, can you tell me what the future value of these cash flows are? And they are 5,000, 5,000, 5,000, but then they change 4,000, 3,000, and 2,000. Of course, one of the ways to do it is to take each one of them separately to the front. But there's an easier way. Once you have the cash flows, you can bring it all back. And then once you get the present value, you can find the future value. Now, here's the thing. If you had bought the B82 Plus Professional, you didn't even have to do it the two ways. You could have automatically given you this number. But you know, it's just one of those, one extra feature you have. But otherwise, the B82 Plus is pretty fine for $28 or whatever we paid for it. So our first job is to put in all these cash flows. Don't forget, we have to start with 0 here. So we have to put in 0, 5,000, 5,000, 5,000, 4,000, 3,000, and 200. So we start again. Press the cash flow button. So let me do that. And don't forget, first press the cash flow button. You have to be in the cash flow. Then you press second and the C/C button at the bottom, so you clear the register, and you'll find the CFO. So 0, enter, down arrow key. It says C01, how much? 5,000, enter, down arrow key. But here, we can take a shortcut. When it says how many times, you say 3 times, enter, down arrow key. So just to refresh your memory, what did we have? We had 0, we had 5,000, 5,000, and 5,000, and then we had 4,000, 3,000, and 2,000. Taking out the 3 zeros out. So I just want to check my recording is going on. That's good to know. So we finished with these 3. Let's put in the 4th one. The only problem with this calculator, it's asking you for cash flow 2, but technically it's cash flow 4. So 4,000, enter, down arrow key. How many times? Just press the down arrow key. Next cash flow, 3,000, enter, down arrow key. How many times? It's 1 is the default, just press the down arrow key. Cash flow 4, 2,000, enter, down arrow key. How many times? Once, just press the down arrow key. You can check to make sure you have all of them in. Press the net present value. It'll ask you what's your net present value, and the problem said you want to discount it at 12%. We do enter, down arrow key, compute, and you get 17,266.77. So the present value of all these payments is 17,266.77. So all of these today is worth 17,266. So once you know that, you can take it forward all the way to 34,081.54. And how would you get that? Well, you'll say negative 17,266.77 is my present value. How many years do I have to go? Let's see, 1, 2, 3, 4, 5, 6. 6 is my N. What's the interest rate? It's a 12. So 12 is my interest per year. There is no payment because it's only one sum. Compute future value, and lo and presto, you should get 34,081.54. Interpretation. Well, if I am expected to receive 555,432, and I put this money in a bank earning 12%, I will accumulate a total of 34,081.54 if the bank pays me an interest rate of 12%. And this value is at the end of the 6th year when I receive my last payment of 2,000. Okay. Of course, if you were in Excel and you put all those numbers there, excuse me, you just have to highlight the numbers. The net present value, 12%, it'll give it to you in one shot, 17,266.77. But before you say, why aren't we always using Excel? Let me tell you that the Excel can only do certain things. Your calculator can allow you to manipulate much more than what Excel can do. So now, let's apply this now to some problems in the real world. So the first one we're going to do is loan payments. Okay, as I have to warn you that this chapter is very long. There are two chapters that are very long in your class. It's chapter 6 and chapter 10, because it's a lot of applications at this point. But let's try to do some applications here. One of the examples you'll always get is what we call loan payments, and these are amortized loans. So let's first clarify that one. Suppose I take a loan of 15,000. So let me write this down here. I'm taking a loan of $15,000. It's for 3 years. Now, one particular type of loan is called the non-amortizing loan. So when it's non-amortizing, then it means we don't pay any principal in between. So in that case, if the interest rate, and let me just go back, the interest rate is 12%, we say, all right, then what happens is, all I'll do is pay the interest per year. So 15,000 times 0.12 means I'll pay 1,800, 1,800, 1,800, and then I'll repay back the principal at the end of this year, so that in year 3, I'll pay 16,800. That's a non-amortizing loan. If it's an amortizing loan, then it's like your mortgage or your car payments. I'm going to look for equal payments. Let's call it X. And, excuse me, and when I finish it, I'll just have to make 3 payments, and that will take care of everything. The principal will be paid in certain amounts over the 3 years, so that I'm completely done, and I don't have to worry about paying a lump sum at the end. So how do we find the present value of that payment? Well, this is exactly where the payment button comes in. All I have to do now is to say, okay, 15,000 is my present value, so I'll make it negative. 3 is my N. 12 is my interest per year. 0 is my future value because I don't have any one particular number here. And say compute payment. Now, of course, you can also do the formula way, but I'm sure you're all going to use your calculator. So when I get that, I get 6245.23. So in other words, if I pay you 6245.23, the bank is actually charging me 12%. Now, of course, you know what's going to happen. Grandmother's going to come into the room and says, I don't think that is correct. You're paying nearly 18,000, looks like nearly 18,500 in total. I think the bank is ripping you off. So how can you prove to grandmother that you're indeed paying 12%? Well, we can do what is called a simple amortization table. And I'm just going to do that here. But the interesting thing is, let me do it the long way, and then I'll do that. All right. Let me just briefly refresh me here. I just need to see what I have to do. Okay. All right. So let's start. In order to prove that you are correctly paying the right amount, let's start in year one. And we'll call this beginning balance here. The beginning balance is 15,000. Now, the payment, remember, these are equal payments. So I'm going to be paying 6245.23, 6245.23, 6245.23. Now, we have to decide, when we make this payment, what proportion of it is interest and what proportion of this is principal. So let me just make sure that I have this correctly done. I have to go back to the top. I knew this was going to happen. So I'm going to press my screen here. Okay. So in order to calculate the interest, no wonder it disappeared. So interest, that's easy. The first year, if I use all 15,000 for the bank's money, then at 12%, I know that the interest is going to be 1,800. So 1,800 is obviously going to be the interest. I paid 6245, so if I subtract this 2, so let me see how much that comes to. 6245.23 minus 1,800 says, then I have paid the bank 4445.23. So then, if I've done that, what's the ending balance as far as the principal is concerned? Well, it'll be 15,000 minus this. So that means at the end of the first year, I will owe the bank 10,554.77. So the first year when I make my 6245.23, it's made up of 1,800 in interest, 44.45 in principal, and that's what I owe the bank at the end of the year. So when I restart the second year, 10,544.77, I only owe the bank that much. So if I make a payment of 6245.23, my question is this: how much am I actually paying? Wait, I can't seem to hold this here. I have to do this separately, is it? So let me just do it. I want to show that to you. Don't know why this is behaving like this. All right, I'm going to do that. I'm Let me take this off. So the amount of interest I'm going to pay you, I'm going to put it right here, is I owe now the bank only 10,544.77 times 12%. Let me see how much that happens. It'll be 1,266.57. So now I have to pay little interest or lower than last year because I only owe the bank $10,000, 10,544. But I'm making a fixed payment, so obviously I'm going to end up paying more principal this time. So I subtracted from 6245.23, and I end up paying a principal of 4978.66. The question now is, if I pay 4978.66, how much principal is left, or have I paid off, or the balance that's left at the end of the second year? So I'll subtract this number, the beginning principal, minus the principal paid. So I'll subtract it from 10,544.77, sorry, 77. And I'll have 5566.11. Let me just quick check to make sure that everything is jiving here. 5566 from 10, that's fine. So now becomes the third year, 5566.11. I make a payment of 6245.23. Now let's see what is principal and what is interest. The interest, I only owe the bank 5566, and if I use their money for the whole year, at 12%, it amounts to 667.93, 7.93, and if I subtract this from 6245.23, guess what happens? 66, and left with a zero payment. I might be off by one, but that would be a decimal problem if it's 1 cent off at that point. So basically you can tell grandmother, listen, I pay the bank 6245.23 every year. I'm correctly paying 12%. They're only charging me for the actual principal that I have used during the year. So the first year I used 15,000, I pay 12% of that. Then I pay off some principal, and on the beginning of the next year, I owe the bank 10,544.77. 12% of that is 1,266.57. The rest is principal, and at the end of the second year, I'm left with 5,566.11. At the beginning balance next year, I pay interest on 5,566.11 when I use their money up for the whole year. That is 667.93. And at the end of the year, I'll be left with the zero balance at this point. 669.32. 5,576.10. 5,576. So somewhere along the line, but I'm going to give you the right number shortly, because as you'll see, you don't even have to do this. All this is available in your calculator. So actually, I'm just going to copy this and bring it back here. And let's do it using the calculator at this point, okay? So in your calculator, this is what you'll have to do. First, you'll have to calculate the payment. So go ahead and do negative 15,000 is your present value. 3 is your N. 12 is your interest per year. 0 is the future value. Compute payment. And you should get 6245.33. So let me do mine again. 15,000 change sign present value. 3 is my N, 12 is my I, 0 is my future value compute payment, And I have, oh, see, I see, that's what happened. It's 624523. Must be getting a little dyslexic. Oh, no, I did have it correctly. Okay. So moving forward, next, what you have to do is you have to press the amort button, which is the, so you want to press the amort button, which is the second and PV button. And when you press that, it will ask you for P1. And then if you press the down arrow key, it'll ask you for P2. Basically, it's asking for which year do you want it for? Tell me the beginning of the year and the ending of the year. So let's say we want to find out the first period, this number here. So in that case, just press 1, enter, down arrow key. So I'm going to press second amort. It asks me for P1. I press 1 and the down arrow key. It asks me for 2. I press 1. I don't even need to do enter actually. Do I? Yeah, I play it safe and enter it. And down arrow key. And guess what's the first thing you'll see? You'll see the balance is 10,554.77. If you press the down arrow key again, it'll tell you principal is 4445.23. That's this number here. Then if you press the down arrow key again, it'll tell you the interest you paid, which will be 1,800. So you've got this complete one row just by pressing the amort button, which is the second PV number. What if you wanted to know the last one here? How much principal and interest did I pay in the last year? No problem, press the amort button again. When it asks you for P1, this time it's year 3, so you press 3. And when it asks you for P2, you press 3, and then I played safe, so let me just go back. I'm going to press the second amort button. Excuse me, second amort. It says P1, I say 3, enter down arrow key, 3, enter down arrow key. So don't forget to press the enter down arrow key. And lo and presto, the balance is 0.02, but basically it's a 0. If I press the down arrow key, it says principal is 5576.10. And then if I press the down arrow key, it says the interest is 669.13. Ah, 669.13. I better change my number because I see this says 669.32, and I know it's a typo because the next number is 2. So it should be exactly 669.13, which I am going to do right now and make sure 13, save this at this point. Okay. So interest payments, you learned how to use the present value payment button today, for future value, present value, and you learned how to do the loan amortization table. Moving forward, there are 2 more topics to be covered. One is the perpetuity and then compounding. So as I told you, it's a very long chapter here. So you may want to take a break and come back or whatever. So let's move on. Let's start now with a series of payments that is called a perpetuity. So a perpetuity is a series of equal payments, but that is promised to pay forever. So for example, you could get a bond that promises to pay you 5% interest on $100 forever. So let's say it's a $100 bond and you got being offered, said, listen, I will pay you $5 interest forever. I won't charge you, I won't give you a principal back, but you'll always earn an interest. How much will you pay for me? So obviously you'll take the present value of all of these to decide what it's worth, but you can't go forever. And by the way, if you say there's no such thing as a perpetual bond, you're wrong, because there are perpetuals being issued even to this date. And for example, one that I mentioned is in 2012, casino operator Genting Singapore issued 1.44 billion of perpetuals at 5.21. If I just click on Google right now and go to Google, I bet you if I click on perpetual bonds, there should be a new issue. Let's see if there's any issue recently. Let's click on news. So here's a bank in China has raised 20 million annually in perpetual bonds to finance its purchase of Swiss seeds from Syngenta, with China becoming the single largest investor, blah, blah, blah. Anyway, it's for real. There are many instruments that are being borrowed where they say they'll pay you interest forever. Well, the important thing to remember now is in order to find the present value, all you need to do is find out the first payment. We call that dividend, which we use D, and all you have to do is divide it by R. So it's as simple as that. It'll turn out to be correct. So let me give an example. So the example is as follows. Let's say there's a company that is giving you a deal that says, lend me some money and I will give you ever 20, let's make it 5% coupon. Oh, no, let's make it, yeah, it doesn't matter, $5. So they're going to give you for every $100, they'll give you 5 forever. How much should you pay? Let's say this is a risky company, so you demand at least to get a 20% return. So then the amount you'll pay is the present value of all of these $5 at 20%. So present value is equal to D1 over R. So it's 5 divided by 0.20. So 5 divided by 0.2 is $25. Okay. So the sum of 5 forever is worth $25. So let's say grandmother comes into the room and says, that's absurd because you recover the $5 in just 5 years. Aren't you paying a little bit low? And the answer is, of course, simple. You say, listen, grandma, I'm paying $25 because the interest rate of $25 at 20%, what is that equal to? It's equal to exactly 5. And remember, I'm not getting the principal back. So I am indeed lending it at $20. So in other words, I give the company 25. At 20%, I'm demanding 5, and that's what they're paying. And the other thing you got to remember is that $5 after year 10, 12, 15 comes to be nothing. It's no value at all. So you're going to recover most of your money in the beginning at this point. So to find the present value of a perpetuity is very simple. We just take the first payment and divide it by R. Okay. So here's another example I've done. I said, here I used 100. A company pays you 100, 100, 100 forever. How much did you pay? You just divide it by 0.20, and the present value is $500. Same argument as you gave to grandmother just now. 20% of 500 is 100, so it makes a lot of sense at this point. Okay, we're done with perpetuity, and we'll have to use it when we're doing the stock chapter. So the final issue is on compounding, okay? So when we talk about compounding, and that's very common in finance, it's a real question of where instruments pay interest more than one time a year. So let me give you basics first of compounding. Let's say you were to borrow, or you plan to invest $100 in a bank, and a bank says they'll pay you 10% interest. So how much will you get at the end of the year? You'll get $10 and your principal, so it's 110, right? Or if you want to do it, 100 times 1.10 is equal to 110. Let's say a competing bank says, you know what, I will pay you 10% too, but my interest payments are semi-annual. In other words, I'll pay you the $10, but I'll pay it to you twice. So in other words, what this bank is saying is, let me put a negative sign here. If you give me 100, I'll pay you the interest of 10. It's 10% still, but in 6 months, I'll pay you 5, and then I'll pay you another 5%. So you say, okay, which one is better? Obviously, this one is better because when you get the 5, you can put this in the bank again. And 5 times 1.05, because now it's only 6 months, will be 525. So what happens is, if you put it in the bank, then the total amount you'll have at the end of the year is 110.25. So you'll get 25% more. So technically, this bank paid you 10% per year, but this one paid you 10.25% per year. Although they claimed it was 10%, but paid semi-annually. So in other words, this bank could have said, listen, I'll just pay you once, but I'll pay you 10.25. But instead they're saying, I'll pay you 10, but I'll pay you twice a year. So if any lender pays you the same interest rate, but in multiple times, then by definition, you are going to be earning more. So let's take an example of someone who pays you quarterly. So if you pay you quarterly, then the $10 of interest is paid like this. And then you're getting your principal back. So 102.50. So what exactly are you earning? Well, you remember this will earn interest, this will earn interest, and this will earn interest. So to do that, I know the interest, or what I'm going to get, is that the future value is equal to 100, but I'm earning 2.5% interest. So it's 0.025, but 4 times. So if I use my calculator and said, okay, 1.025 yx 4 times 100, I'm actually getting $110.38. So my real interest is 10.38%, which is even better than the 10.25 that I earn with semi-annual coupon. So that should be clear. The more frequency they pay, the more you take ownership of your own money earlier, and therefore you can reinvest it and end up with a higher payment at this point. So let me move forward. I think right here is a good example. So the same example we did. If it's annual, I'm sorry, this should be 1. What is this doing here? It's 110. If it's semi-annual, it's 110.25, 38, 47 daily, and continuous. If they pay you monthly, you get 110.47. If you get daily, you get 110.52. And now we're going to learn continuous, which is 110.52. But remember one thing. Look at the difference. If you went from annual to semi-annual, you make 25 cents more. When you go from semi-annual to quarterly, you make about 13 cents more. When you go from quarterly to monthly, you make about 9 cents more. From monthly to daily, you make about 4 cents more. And then daily to continuous is in decimal places at this point. So I'm going to go back and say, here is the formula. It looks fancy, but it's exactly what we did here. Here is the formula to get the future value. It's 1 plus whatever is the quoted rate. I'm using QR because that's what your textbook uses. So in our example, let's say we're going to do the monthly rate. So the future value is equal to $100. 1 plus the nominal rate or the quarterly rate is 10, but we'll have to divide it by 12, where M is the amount of subperiods. And then I'm going to do times 12, because I'll earn interest of around 0.8% every month for 12 periods. Okay, so that's exactly the formula that we use. Let me just see if I can shade this. Yes, I can. Take that out, take it out. So if I want to do it for, let's say, quarterly, then future value is equal to 100. 1 plus, remember it's 10%, I'm going to divide it by 4. So the quoted rate is 10 divided by 4. And then for 1 year, it's 4 times 1, so I'll multiply it by 4. And that will give me exactly as I did earlier, 110.38. Now, with the same thing, we can also do what we call the effective interest rate. And remember the example that we did. It's the example, the first one we did with semi-annual. This bank paid 10%. This bank paid semi-annually. So the effective rate you got with this is 10.25%. That's called the effective interest rate, because it's like telling the bank, just don't give me all this semi-annual stuff, just give me 10.25%, because that's the effective interest rate you're paying me, even though you're paying 10 nominally, 5 and 5. But because the 5 can be reinvested, it's actually higher, so this is the true rate. So the interest rate is the true rate you're getting on an annual basis. Same formula. To do the effective interest rate, you do 1 plus QR of M minus M, but you subtract it from M, from 1 to get the effective rate. So in a semi-annual, it's 1 plus 0.10 divided by 2, take it to the power 2, and subtract 1, and you get 0.1025 or 10.25%. So now let's go to continuous compounding. Continuous compounding is at the extreme level. So remember, we can give you interest every 6 months. We can give you interest every quarter. We can give you interest every month, every day. every hour, every minute, every second. At the ultimate, we have what is called continuous compounding. So the formula for that, whether it's future value or present value, is as follows. So the future value formula is you take the present value and you do e to the power RT. And if it's present value, you do take the future value e to the power minus RT. So let's do an example in our case. In our case, the present value is as follows. Let's do the future value first. The future value is equal to $100 e to the power RT. So what was the interest rate? It was 10%, so it's 0.10. Now it's a formula, so it would 0.10. And let's just assume it's 1 year for the moment. That's the example we did earlier. So how do I get this number? Well, in your calculator, you press 0.10 times 1, so it's 0.10. And then you'll see the button e to the power x. So your BA2 plus, that's the same as second and ln, which is on the left side. So I'm going to press 0.10 second ln, and it will give me 200. It'll give me 1.10511709. I'll multiply it by 100, and that's what I get, 110.5170918. So if we go back to my table here, that's what you see, 1110.5171. And that's how I got the rate at this point. So we've done compounding. Now let's do an example. And the example is as follows. I need to pause the recording for a second. So the example says a bank is offering 12% compounded quarterly. How much money will accumulate? How much money will accumulate? How much money will you accumulate at the end of 2 years if $100 is deposited today? What is the effective interest rate? So all you say is, all right, I have my future value. I got my formula before. My formula said future value is equal to present value 1 plus the quoted rate, as I used in the book, times M. So in this case, my present value is 100. My quoted rate is 12. I'll divide it by 4 because it's quarterly, so it becomes 0.03. And I need it for 2 years. So remember, this formula is M times T. So there'll be 8 quarters in the 2 years. So it'll be 4 times 2. So it'll be 8 quarters. That means I'll earn, at the end of 2 years, I'll earn 126.68. The next question said, what is the effective interest rate? So I go, okay, if you want the effective interest rate, let me just shade this and take away. The effective interest rate says, let me write this down. Effective interest rate is 1 plus the quoted rate divided by M to the power M, and then you just subtract it from 0. So if I did that, I don't need the 100 because I just want the rate. 1 plus 0.12 divided by 4 to the power of 4 minus 1.0. So it's exactly what I have here. Is my annual rate is 12.55%. So why am I doing this? Because I'm basically telling the bank, listen, forget this 12% compounded quarterly rate. Just tell me what the annual rate is you're giving me. And the bank will say, all right, if you want that, I'll give it to you at 12.55%. So then let's see if this is correct. So that means I can earn 12.55 for 2 years on my $100. Does that work out correctly? Let's see. $100 is what I have. 1.1255 to the power 2, and lo and presto is the same amount, 126.68. So in other words, the bank could say, I'll give you 12%, but I'll pay you every quarter. Or I can just give you 12.55% per year. Either way, you'll come out with the same amount at the end of 2 years. So that's, essentially the relationship between the effective annual rate and the quarter and the compounded rates. To finish off this chapter, what if you knew the effective rate, but you need to know what the quoted rate should be? So, for example, let's say a bank wishes to give a rate, they want to earn exactly 18% at this point. So what rate should it quote on a monthly basis? They want to compete with another bank and say, listen, I'd like to quote a rate, but I don't want to charge 18% as such. I want to charge something that's a little bit lower, but I'll pay them monthly at this point. So then it's essentially the reverse. You're trying to find out QR. What should I quote it when M is 12? When M is 12. So but the effective rate, I wanted to end up to be 18%. So basically, we're doing a reverse formula here. We're saying, give me 18%, 1 plus QR. I have all the numbers, so solve for QR. So this is a little bit of algebra. So let me see, let me do that. I'll just do it in the Word document. Where's my copy command? So I'll go right here and I'll print it right there. Oops, wish I could print it here. Okay, let's do it here. So how do I solve for that problem? Well, just remember it's 0.18 is equal to 1 plus the quoted rate divided by 12 minus 1.0. So first, take this 1.0 to the other side. So it becomes 1.18 is equal to 1 plus the quoted rate over 12 to 12. Now, how do I remove something like this? If I can take it and multiply this by 1 over 12, I'll remove this and I'll have to do the same thing. I'll have to put the 1.12 here. Again, later on, I'll show you how to do it using your calculator. But in order to do that, you go 1.18 yx in your calculator, 12, and 1 over x, and you'll get this number. So let me do that. 1.18 yx 12 inverse equal to, I get 1.013888 is equal to now this number here at this point. So I'm going to go back to my thing here. Oh, I didn't show you how to do it. So going back, I will take this side, so it'll become minus 1. So 0.13888 is equal to QR over 12. And so QR is equal to 0.013888 times 12. So I multiply by 12 and I get, oops, why do I get a different number? Let me just check that. Yx 12 inverse equal to minus 1 times 12 is 0.16667 or 16.67%. So what the bank should say is, I will give you 16.67%, but I'll pay you monthly. And in effect, what they're doing is paying you 18% at this point. So you disturb me, my God. Okay, let's see. All right, hopefully I can edit this. My wife keeps bothering me. I tell her not to disturb me. Anyway, the way to do it in your calculator is you put -1 as your present value. Let me increase this output. To 1.18, which is what you want as your future value. 12 is your N, 0 is your payment, compute interest per year, and you will get exactly 1.388, which is your monthly payment. Multiply by 12 and you'll get 16.67%, and that's your answer. So I'm not sure if the thing is still continuing to record or not, but assuming it is, then we will continue when we have our class, next class. I will go over some problems, but hopefully you've understood this chapter, and all of this is there. The PowerPoint is also there, and you have problems at the end of the book. That's what I'm going to do, some of the problems at the end of the book for chapters 5, 6, and 7. Thank you.